So in previous lecture we have discussed about the first order RC circuit problems, and we have developed some unique steps uh, how to deal with the problems related to RC circuit. Now the rest problems what we have left in the previous lecture, we are going to continue from that section. Okay, we have done up to 12 problems in the previous lecture. Now starting with the next problem, that is the 13th one. See, in this circuit it is given that the input voltage VIT is constant at 2 volt up to what, 1 second, and abruptly it changes to 1 volt after t greater than 1 second. So it is asking about the V0 voltage after the change will occur exactly at 2 seconds. Okay, so let's see. If I'm asking about in this problem, if you do this problem on the same step what we have discussed, then see here actually at what position the switching action is taking place. You can see here just before 1 second the voltage is, it is saying that its value is up to 2 volt, and exactly at 1 second its value is getting changed at 1 volt. That means we can say that the switching action is taking place at t is equal to 1 second, not at t is equal to 0 second. Okay, so we can do this problem in the same manner. What we will do, from the supply waveform it is clear that the changes occur at t is equal to 1 second. Switching action is taking place at 1 second. So now we have this t is equal to 1 second as what, at t is equal to 0 position. As why I am doing so, because we have done every problem just before t is equal to 0 and just after t is equal to greater than 0. So I am be having this t is equal to 1 second as a t is equal to 0 position, and when we will get a final answer with respect to t is equal to 0 position, what we will do, we will just delay the t by 1 second. That means we will replace that wherever we get the value of t, we just replace it with t minus 1. Okay, what is this one? This is delayed by 1 second na? From t is equal to 0 position. Okay, so let's start with the same aspect. First step is what? Case 1, t is equal to 0 minus. What will happen? Capacitor will behave like a open circuit. Capacitor will behave like open circuit. This is 1 mega ohm. This is the supply voltage 2 megavolt. Okay, this is 2 volt. T is equal to 0 means I am behaving t is equal to, actually I am saying about t is equal to, this is 1 position. I am behaving this as a 0 position. Okay, so just before it, how much it is voltage? That is 2 volt. So VIT will be 2 volt. That's why I have written here t is equal to, that is 2 volt. Okay, now in this circuit if you see what is the value of VC0 minus, that is exactly equal to 2 volt because there is no current in this. Okay, now case 2, at t is equal to infinite second, what is happening? The value of the voltage VI is getting 1 volt, so I have taken this 1 volt, and again the capacitor will be open circuited. What you will get, VC infinite will be exactly equal to 1 volt. Now the next step is what? That is to get the time constant value, that is RTH into C equivalent. Okay, so it is always calculated for t greater than 0, and what we will do, the independent voltage sources short circuited, independent current sources will be open circuited. So let's draw the circuit for t greater than 0, or always remember I am having this t is equal to 1 as a 0 position. So after this one, what is happening? Vi, how much? That is equal to 1 volt. So I will write it here 1 volt, but while calculation of the time constant, this must be short circuited. This is capacitor, this is 5, this is how much? This is 1 mega ohm. Okay, this is 1 mega ohm, this is 1 mega ohm. Okay, now see, if I calculate the RTH, I have already told in many problems we have done this concept. RTH is 1 mega ohm, C equivalent is 1 microfarad. If you find the value of tau, that you will get, that is 1 second. Now last step is what? That is finding VCT, and VCT we know that what is the value of VCT? VC infinite plus VC0 minus VC infinite e to the power minus t by tau. Put all the values, that is 1, this one is 2 minus 1 e to the power minus t by 1. Okay, so VCT we will get this amount of value. Okay, now the next, actually what it is asking about, it is asking about v naught t. And if you want to calculate the v naught t means the voltage across this resistance, and the voltage across this resistance can be calculated if we know about the current flowing through this resistance, and whatever current will flow in this capacitor, that will also flow in this resistance. So we will calculate the current flowing through this capacitor, and we can easily calculate the value of ICT, that is equal to C dVc by dt. VCT we know, put this value differentiated, you will get ICT is equal to this amount. So V naught is equal to, finally V naught t is equal to ICT multiplied by 1 mega ohm. Okay, you will get this amount. Is it okay? So V naught t we have got e to the power minus t u of t. But what we have done, we have assumed that t is equal to 0 position in place of t is equal to 1 position. Okay, now what I have told at the starting of this problem, I have told that in final answer just replace t is equal to t minus 1, you will get the same expression. So just put it t is equal to t minus 1 here, you will get v naught t. What exactly in the question is asking, that is e to the power minus t minus 1 u of t minus 1. Okay, now I have to calculate the value of v naught t for t greater than 2 seconds. For t greater than 2 seconds, you can choose any amount of value, that is 3 seconds, 4 seconds and 5 seconds. I have taken here t is equal to 3 seconds. Put it here, what you will get the value e to the power minus 3 minus 1, that is equal to minus e to the power minus 2, and this is the right answer for this problem, whatever the option has been given. In this problem, it has not been mentioned that exactly at what time the value has to be calculated. I have just taken it 3. If you take it 4, you will get different value, but in the option, whatever the option is available for t greater than 2 seconds, that is only minus e to the power minus 2 volt. Okay, so option A is correct. Now moving to next problem. What is this problem? A square pulse of 3 volt amplitude is applied to CR circuit. This is the CR circuit. A square pulse has been applied to it. The capacitor is initially uncharged. It is saying that VC0 is equal to what? That is 0. The output voltage V0 at the time t is equal to 2 seconds will be. Is it okay? So let's see. We will move forward in the same manner as we have done in previous problem also. First we will calculate VC0 minus and VC infinite, then we will find time constant, then we will find the VCT value, then we will find the other responses are, that is equal to V naught t. If you see clearly this waveform, can it design this waveform? How you will get this such type of waveform? We can get such type of waveform. I'm just breaking this waveform. If you break this waveform, what you will get? You will get like this waveform. This waveform can be represented as x1 of t, that is equal to 3 volt. Okay, now exactly at t is equal to 2 seconds, I'm just representing x2 t, that is equal to also 3 volt, and it is like that. Now add it up. These two waveform has been added up. If you add it up, these two waveform, you will get this amount of waveform. Why? Because exactly after t square, don't add it up, just subtract these two waveforms, x1 minus x2. If you do, what you will get at 0 position, how much value you will get? This is 0 and this one 3. 3 minus 0, that is equal to 3. Exactly 2, how much you will get? This is 3 and this is 3 is equal to how much? That is 0. Then after at 3 second, what will happen? This is 3 and this is 3. 3 minus 3 is equal to 0. That means this waveform can be split into two types of waveform, x1t and x2t. Okay, so we can say that now the input voltage is exactly equal to x1t minus x2t of. Okay, so the responses will also be what? In the same manner, we will calculate the response corresponding this signal, we will calculate the response corresponding this signal, and finally we will subtract the response. We will get what? The final expression for the VCT. So if I am calculating with respect to x1t signal, this is u of t signal, what I will get? VC1t is equal to VC1 infinite plus this is the expression for VCT calculation. Okay, now you see VC1 infinite will be how much? VC1 infinite will be how much? VC1 0 minus how much? VC1 0 minus, it is already given that is equal to 0 volt. Okay, if it is 0 volt, then VC infinite, just see this one, just see this one. What is happening? V input will be for x1t. V input will be for x1t. How much you will get? You will get V input will be for t infinite will be how much? This is 3 volt, and capacitor will be open circuited. If capacitor will be open circuited, what is happening? If this will be open circuited and this one is equal to 3 volt, this is what? Then Vc infinite how much? This is exactly equal to whatever the applied voltage will be here, that is equal to 3 volt. Okay, now time constant will be this R and this one C, then R into C, that is equal to time constant. What I have got, Vc1t is equal to this amount. Similarly for x2t signal, what I will get, same manner. Okay, infinite value will be what? That is equal to 3 volt again. Why? Because after t exactly equal to infinite value, how much value it is showing? That it is showing that it is equal to how much? That is equal to 3 volt. Okay, so this one is 3 volt, this one is already 0, this is 3 e to the power minus t by tau. But see here what is happening, this signal is not starting at 0 position. So in the final expression, what I will do, I will just delay this signal by 2 seconds. Then the final expression for Vc2t is equal to 3 1 minus e to the power minus t minus 2 by tau. Is it okay? So now the total response Vct will be what? Vc1t minus what? Vc2t. Why? Because this due to this signal and this due to this signal, both responses will be subtracted. If we subtracted both response, Vct will, you will get Vc1t minus Vc2t. Okay, just take it minus. Okay, and tau you have already found out. Okay, now you have to calculate the V naught t, and we have seen that V naught t will be, what is V naught t? V naught t will be this resistance multiplied by current flowing in this resistance, and the current flowing in this resistance will be exactly equal to the current flowing through the resistor, through this capacitor. So current flowing through this capacitor can be calculated as we have already calculated Vct. So Ict will be C dVct by dt. Okay, so Ict will be calculated C Vct dt. If you differentiate it, you will get the value of Ict, and finally you just multiply with Ict into 1 mega ohm. What you will get? You will get the value of what? V naught t. This is V naught t. Okay, if it is asking about at t is equal to 2 seconds, then what you will do? Just put the value of t is equal to 2 seconds. What you will get? You will get the value of what? V naught 2, that is equal to minus 3 volt. Okay, you do all these calculations. You do all these calculations by yourself. Now the next problem, in this problem what is saying that an 11 volt pulse of 10 microsecond duration is applied to the circuit shown in figure, assuming that the capacitor is completely discharged prior to applying the pulse. The peak value of the capacitor voltage will be. Okay, let's see. This position is what? 10 microsecond. This position is what? 0. It is saying that capacitor is completely discharged prior to the applying the pulse. Then switching action is what? This one is the switching action. Okay, 10 microsecond you are getting a pulse of 11 volt. Before 10 microsecond, what you are getting? You are getting a 0 amount of pulse. Okay, and it has been mentioned that the initial voltage across the capacitor, that is equal to how much? That is 0. So we have to calculate what? We have to calculate the capacitor voltage value. Okay, so if we want to find the capacitor voltage, the steps are what? First step, at t is equal to 0 minute, it is given that the capacitor is completely what? Discharged. If it is completely discharged, that means what is the value of Vc0 minus? That is equal to 0 volt. Okay, so next one is, next what you will do at t is equal to infinite. If I will do at t is equal to infinite, what will happen? Capacitor will behave like open circuit. T is equal to infinite, what is the voltage? The voltage has been applied after t is equal to 0. That is how much amount? That is 11 volt. If it is an 11 volt, this is open circuit voltage. This voltage will be exactly equal to the voltage across this 10 kilo ohm resistor. So we can apply voltage division rule. We will get Vc infinite is equal to 11 into 10k divided by 1k plus 10k. That is equal to how much? 10 volt. Now the next step is what? Finding the time constant, that is equal to RTH into C equivalent, and it is always calculated for t greater than 0, and all the independent voltage sources will be short circuited and the current sources will be open circuited. If we draw the circuit, what will happen? This is the circuit for t greater than 0, but this voltage will be now short circuited. This is short circuited. This is 1 kilo ohm, 10 kilo ohm. This is a capacitor. Across this terminal, if you find RTH, what will happen? This 1k and 10k will be in what? Parallel. If it will be parallel, RTH will be what? 0.909k, and C equivalent will be 11 into 10 power minus 9 farad. So tau will be RTH into C equivalent. If you do, what you will get? That is 10 microsecond. Now the last step is what? Finding VCT. If I will calculate the VCT, we know the value of VC infinite, we know the value of VC0 minus, we know the VC infinite, we know the tau value. What you will get? You will get VCT is equal to 1 minus e to the power minus 10 by 5 t volt. Now it is asking the peak value. Whenever the peak value will occur, when you apply a pulse of 11 volt that has been applied at 10 microsecond, that means VC 10 microsecond will be, put the value of t is equal to 10 microsecond, you will get the value of what? You will get the value of VC10, that is equal to 6.32 volt, and hence the option C is what? Correct. Is it okay? Now the 16th one is what? It is asking about the total energy absorbed, by the 4 ohm resistor from 0 to infinite will be. This is 4 ohm resistor. Okay, so how you will do? VC0 minus has been given to us. Okay, the energy is equal to how much? That is integration of instantaneous power, that is known as energy, between the time interval is what? 0 to infinite. And the power in a resistor, that is equal to I square into R, and I is what? That is the current flowing through the capacitor, and current flowing through this capacitor can be calculated only if we know the voltage across this capacitor. So the main motive is what? We have to calculate first what? VCT across this capacitor. So step 1 is what? At t is equal to 0 minus, what is happening? At t is equal to 0 minus, VC0 minus given 6 volt, so no need to any calculation. At t is equal to infinite, capacitor will be open circuited, this is 10 volt, so VC infinite will be how much? That is equal to 10 volt. Now step 2, time constant calculation. It is always calculated for what? T greater than 0, and for t greater than 0 the circuit will look like this one, but this voltage source will be short circuited. This is 2 farad, this is 4 ohm, RTH is 4 ohm, and C equivalent is 2, then tau is equal to how much? That is 4 into 2, that is equal to 8 second. Now step 3 is what? Finding VCT, and we can easily find now VCT because we know the value of VC infinite, VC0 minus, and this is tau. If you do calculation, you will get VCT is equal to this amount of voltage. Okay, now the value of ICT is equal to C d VCT by dt. Differentiate this amount of, you will get what? This amount of what? This is ICT, and this is the same current flowing in the resistor. Okay, so energy dissipated in the resistor will be what? From 0 to infinite, IRT square into R, and we know that this current and this current is same because it's a RC series circuit. Then IRT we have already calculated this amount of. Okay, just make integration here. I have made it integration here and put the limit 0 to infinite. What value you will get? You will get its answer will be what? This is 16 joule, hence the option B is correct. This is 16 joule, hence option B is correct. Okay, so and finally ending with the last problem. What is this problem? Determine the value of VCT for t greater than 0. You see, these are the two voltage sources connected in series. Okay, if we want to make a single voltage source, what we will do? We will write u of t minus t plus what? 2 ut, because two voltage sources is connected in series, they can be added up. Okay, so if we draw these two signal, u of minus t, that is, this one is what? U of minus t. Similarly, if we draw 2 ut, What is this signal? This is 2u2. Okay, now the combination of these two will represent what? This signal up to what? This is u of minus t plus what? 2ut. If you do adding up these two signals, what I will get? I will get this amount and this amount. This is what? This is the total input voltage applied to. This is what? This is VIT. Okay, now see, it is asking about VCT. So now the same steps we will take. First, what? At t is equal to 0 minus, what is happening? At t is equal to 0 minus, how much input voltage is? That is equal to 1 volt. So I have taken 1 volt. Okay, this signal will not work. Why? Because it is defined only for t greater than 0. Okay, now draw the circuit. Capacitor will be open circuited. If it is open circuited, this voltage will be same as this voltage. Why this voltage? Because this current will be 0. So how much voltage will be here? You can easily calculate by using voltage division rule. 2 into 1 divided by 2 plus 2, that is equal to 2 by 4. That is equal to how much? 0.5 volt. Similarly, at t is equal to infinite, what is happening? At t is equal to infinite, the how much input voltage is? That is equal to 2 volt. So I have replaced this one was 2 volt. This value is what? This is not defined for t greater than 0. So that means it is 0, and this will be open circuited. VC infinite again will be the voltage across this 2 ohm. This 2 ohm voltage can be calculated 2 into 2 divided by 4. That is equal to 1 volt. Now the finding the time constant is always calculated for t greater than 0, and this circuit is representing for t greater than 0. But all the independent voltages will be short circuited. So we have drawn this circuit. RTH across this terminal, this will be 2 in parallel with 2 plus what? 1. 2 in parallel with 2 in plus 1, that is equal to 2 ohm. C equivalent is 1 farad. So time constant will be how much? That is equal to 2 seconds. So finally VCT is equal to, we know the formula, VC infinite plus VC 0 minus VC infinite e to the power minus t by tau. So final expression is this. This is all about for what? RC circuit, first order RC circuit. So up to now we have done the order of circuit, different types of responses, first order RC circuit, and I have solved approximately 14 to 15 problems based on first order RC circuit. And please strictly follow these steps, as these steps are going to be very helpful. And and you have already seen in every problem I have used all those 3 to 4 steps what we have discussed at the starting of the first order RC circuits. If you do things in a proper manner, you will never get a wrong answer, and your concepts will be better. So try to do some more problems, accept all these problems, but learn first all these problems, how the problems has been solved and how it must be approached. The approach towards problem solving is very important. What should be the first point that must strike to the mind to get a right answer for the problem? So whenever you see a first order RC circuit, always try to apply all these 4 to 5 steps. You will definitely get the answer in that problem. If the circuit is not type of first order, then never try these approaches. I will explain all things in the upcoming lectures. Okay, so in the next lecture we will discuss about RL circuit and the problem based on t is equal to 0 plus conditions. And the problems based on t is equal to 0 plus condition is very important for ESE and gate point of view. So for doubts, just post your queries on No Problem Facebook group. Thank you very much.